and welcome to Your Favourite Teacher. Today we'll be looking at electrical energy transfers. As we've looked at in a previous unit, there are energy stores and energy transfers. When current flows, work is done and energy is transferred. For example, if there is a motor in the circuit, energy will be transferred to the kinetic energy store of the motor. If your mind is completely blown by this, go on to our lesson on energy transfers in a system. We also know the amount of energy transferred is dependent on the charge, flow, and the potential difference. We can calculate the energy transferred using the equation energy transferred equals charge flow times potential difference. For examples of how to use these equations, go to our lessons on current, potential difference, and resistance, and power. There are also two other equations that you can use to calculate the transferred in a component. The first one is, that's enough now. The equation is power equals current times potential difference. And of course, every physicist's favourite joke, what is the unit of power? So power should be in watts, current should be in amps, and potential difference in volts. Let's look at a question that uses this equation. Calculate the power of a hairdryer that uses 5 amps and 230 volts. Give your answer in kilowatts. We need to substitute the values from the question into the equation power equals current times potential difference. So 5 equals 230, which equals 1,150 watts. To convert this into kilowatts, we need to divide by 1,000. So 1,150 divided by 1,000 equals 1.15 kilowatts. The second equation you could use is power equals current squared times resistance. Resistance should be in ohms. Let's try another question. A motor with a 60-watt power rating is placed in a series circuit with an ammeter. The motor has a resistance of 9 ohms. What is the reading on the ammeter, which has a precision of 0.1 amps? The first thing you need to do is substitute the values in the question into the equation. Power equals current squared times resistance. So 60 equals current squared times 9. You then need to rearrange the equation to find current. So it'll look like this. The square root of 60 over 9, which equals 2.58. However, the ammeter will only measure to the nearest tenth, so we need to round our answer to 1 decimal place, which is 2.6 amps. So to summarise, there are a few equations you need to know to calculate energy transferred and power. They are energy transferred equals charge flow times potential difference, energy transferred equals over time, power is current times potential difference, and power is current squared times resistance. I'm Miss Meeks and we've been looking at electrical energy transfers with your favourite teacher.